Hello guys, and welcome back to another guide. Okay, another piece of lab kit, another bit of kit that's used for every single circuit that you ever build. Okay, well, maybe not every single circuit that you build, but it's a predominant one. Okay, now then, what we're going to be talking about are DC power supplies. More specifically, the Benchtop variety that you used for test and measurement. Okay. Now then, the DC power supply, okay, gives you a DC voltage. Okay. It can either be a variable voltage supply. Okay, you can vary the voltage between different values, or it can be a fixed supply. Okay, so it gives you just one value or multiple values of various fixed voltages. Okay, so on my whiteboard there's a couple of pens. I've got a few pens here. Okay, brilliant. From the top, DC power supply is basically front panel. Okay, there it is, and it will have a couple of terminals at the bottom. You'll have a red one, and generally you'll have a black one, and you'll have a nice green. Okay, why are they red, black and green? Because of colour coding. Green is the earth, okay, and earth is the earth, okay, it's what you're standing on, okay. Sometimes it's called earth, sometimes it's called ground, okay, but ultimately, okay, this terminal here is connected to the chassis, okay, and it's also connected to the mains plug, okay, and it goes off to the wall, and you've got the mains lead which goes off and connects to the earth, okay. You've got a nice picture of the earth there, okay, nice. Okay, and the way it's connected to earth is it's a big metal spike that's driven into the ground. That's what it is. Okay, and use the earth as the as your neutral, as your reference. Okay, now be careful, you don't measure with reference to this, you measure with reference to where your positives and negative supplies are on your power supply, okay? And that's here, we've got a black terminal which is 0 volts, well, not really 0 volts, but it's actually negative volts, okay? Got to be careful, negative volts, and a red terminal which is positive volts. Now, like I said, this black one can be 0 volts, but this red one can be 0 volts as well. Yep, a positive can be 0 and a negative can be 0. Because what is 0? Well, 0 is nothing. Okay, it's a anything value. 0 is. Okay, if I said to you, right, well, what's positive 0? What's the difference between positive 0 and negative 0? Is 0. There's no difference. They're both the same. Okay, so first rule. Okay. Power supplies, this is what we call a floating power supply, okay, and the potential between these is fixed for a fixed supply, or it's either a variable potential if it's a variable supply. Normally there'll be a knob on the front panel called volts, okay, and if you turn the knob it'll be variable. If it doesn't have a voltage it'll be fixed, and it'll be say I don't know, say 5 volts. Okay, it won't tell you positive, it won't tell you negative, it will just tell you 5 volts because it's a floating voltage, and the floating voltage is a potential voltage, okay, it's a potential, and it's a potential between 2 points, a high side and a low side, a positive and a negative, essentially, okay. So, if this was 5 volts, then this terminal, this red one, is 5 volts above the negative, and the negative is 5 volts below the positive. So if we said negative was at 100 volts, positive would be at 105 volts, because there's a 5 volts difference, okay? but you measure everything with reference to 100 volts, it becomes 5 volts potential. Okay, so that's that. The same could be said negatively. If this was 105 and this was 100, again it's negative 5 in that direction. Okay, brilliant. What happens if you want 0? Well, 0 is over here, but you have to remember current flows from positive to negative. Okay, it doesn't flow from positive to the earth what you're standing on. Okay, otherwise every time you touch the earth you'll get a nasty shock, won't you? Simple. Okay, your circuit is goes here. Okay, it's between these 2 points. Okay, where your potential is. If you want one of these to be 0, then you plug it into the earth. So this becomes 0 volts. So we've got 5 volts. You force this one to be a neutral voltage. Okay, let's say 0 volts. This is now 5 volts fixed. Okay, 5 volts positive. On the other hand, okay, if you had your earth connected to positive, okay, this would swing it to this would say effectively call this 0, and this would be negative 5 volts. So you can get a negative and you can get a positive from a desktop power supply. Simple. Now then, power supplies don't only give you voltage, they also give you a current. Okay, you have to remember that. And all power supplies are have current ratings on them. If you take a look at power supply, let's take a computer power supply. Okay, it's normally given to you in watts. Okay, and it always gives you in watts because you've got various power source and voltages coming out of it at different currents. Okay, and it gives you an overall picture of how powerful that power supply is in terms of watts, but it is an actual when you crack open the box or you look at the back of the packaging, okay, each voltage it will be denoted with a current rating. Now that's not the current that it supplies. Okay, it doesn't supply with a constant current. Okay, so if it says 5 amps, when you connect up your circuit, don't expect 5 amps to come out of this power supply. Okay, because it won't. The actual current rating is there. It tells you the maximum current which your circuit can draw. Okay, and it's the maximum current. So if your circuit is powered with 1 volt and you used a 1 ohm resistor, okay, then 1 amp of current would flow. So regardless if this was a 5 volt power supply, only 1 amp of that 5 amps would actually flow. Okay, because you're well, going back to the basics again. I mean, I've spoken a million and one times about Mr. Ohm. Okay, his famous law. Okay, Ohm's Law. V equals IR. Okay, if you have a fixed voltage source, okay, which is what our supplies give us. Okay, depending on the resistance or the impedance of your circuit, that's how much current flows. Simple. Now then, down on my desk here I've got 2 examples of power supplies, so let's have a look. And then 2 power supplies, okay, 2 benchtop ones. Okay, I've got an old one up here and I've got a fairly modern one down here. Okay, there's no major difference between what they do. They're both DC power supplies, they're both supplied with voltage, and they've both got maximum current ratings. Okay, but a DC power supply is the most simplest form of lab kit, I think, that there actually is, and there's not really that much to them. Okay, if we take this top one first, the old one, okay, we've got this is a TOPS 2, which Farnell made, and they used to make absolutely billions of these sodding things. Okay, they're very robust, they're very good, they're designed really well, and they can take a right hammering. Okay, and they still work, and this one still works now. This one's what, about 15 years old, I think, probably older, but it's still going strong, and it's still outputs the right voltages, and the current limits are still what they should be, and they're just excellent units, and they're still used around the world today, even though they're still not made. They're not made anymore. They're still going strong. Okay, and down below I have a Thorbian Thunder TTI DC power supply. Okay, and another very good one. The only real difference between these two, this one's got a display, and it gives you a much wider variable voltage than this one. Okay, that's the only real difference. Okay, and as you can see, we've got our 1, 2, 3 outputs. Up on this one, we've actually got 3 outputs as well. We've got one output here. Here we've got a split supply, which is actually 2 supplies in one. It just gives you a negative supply and a positive supply. Okay. Over on this side, it's only gives you a single voltage output. Okay, of 5 volts. Down on this one, okay, we've got 3 independent ones. We've got a 0 to 30 volt supply, a 0 to 30 volt supply, and a 1.5 volt to 5 volt supply. Brilliant. What more can you say about these? That's all they are. That's all they are, and they give you a DC output. Now then, like I said about current rating, this top one, this tops 2, but the tops power supply, gives you, on the 5 volt side, it gives you up to 5 amps of current, so 5 volts, 5 amps is its maximum. On the 15 volt supply, 15 volts at 1 amp. Okay, you want a higher voltage, you've got to draw back off the current, okay, because you want to keep that power D constant, so you don't have to beef up the components. Down on the TTI, okay, they're all rated at a maximum of 2 amps. So if you want a high current, okay, output, you can use the tops. If you want you're not too bothered, you want a wider voltage range, you can use a TTI. So having 2 different styles of power supply is always good. Just like any other lab kit, it's always best to have more than one type. You never know what you're going to use or what you're going to need. And that's what they are. So next, I guess it's time to show you how to actually use them. Okay, like I said, on going back, you've got the variable supply knobs. You've got coarse, fine. We've also got current. Okay, I'll be speaking about that one when we come to setting up these boxes. Won't really bother too much with the tops power supply, because it is more or less what it says on the front panel, and once you learn how to use one, you can drive absolutely any of them. They're more or less the same. Okay, DC is a flat line. Okay, how many different DCs can you get in the world? It's not many. Okay, well, absolutely tons, but different style, different look, same function, same output, same everything. So we'll just learn you how to use one, and you'll be able to use absolutely any. Okay, here we are. Okay, I've got a little potential divider circuit made here. Okay, 2 resistors, 2 10 ohm resistors in series, and hooked up to the breadboard with a couple of 4mm wires. Let's plug it into the power supply, switch it on, and I'll show you how to use a power supply. Okay, and all these terminals down here, they're all 4mm terminals, following colour code: red to red, black to black, red to red, and black to black. Okay, that's how you connect it up. And then we switch on. There we have it. Oh boy. Now then. Whew. That's how you don't do it. Okay, and that's what I see a lot of people do when they start using a DC power supply. They build their circuit, they plug it in and they press the on button. Unfortunately, that's completely the wrong way how to use a DC power supply. And as you saw, I've now got a black and charred mess down here. My circuit's wrecked, I'm going to have to rebuild it and start all over again. Okay, so how do you avoid doing things like that? Okay, now in this case we were quite lucky because they were just resistors. Okay, I just burnt, I don't know, 2p, 1p. Okay, if that was a microcontroller, a nice expensive high precision amplifier, or a nice expensive digital control circuit, etc., or someone's prototype that they've been working on for the past year, I don't think that you'll be the flavour of the month, and if you was working for someone, I dare say that they'll give you the boot out the door, okay, because you just wasted a ton of money. So it's always good never to turn on your power supply with the wires connected. Why? Because what does this display say when it's off? It doesn't display anything. Okay, this voltage could be set to anything, the current limit could be set to absolutely anything, and it's very easy to burn your circuit. You know, I've had some people turn around and they've built a circuit, they tested it. Oh dear, wrong voltage value. Okay, quickly turn it off, set it up right, switch it back on, and they sit down for hours on end, plodding away with their circuit and their prototype board, and you know, it's a case of this definitely isn't working right. And well, that's because you set up the power supply wrong the first time round. It doesn't matter if you switched it off quickly or you switched it on, switched it off quickly. You know, that source was set wrong, and you damaged the circuit. It doesn't have to be on for a second, it only has to be on for milliseconds and you do the damage. Okay, so how do you set it up? Well, first thing, don't have anything connected and then switch it on. Okay, so as we can see, this is actually set to 22.3 volts, way above what it should be for that particular circuit, which is why resistors burnt so violently, so brightly. And believe it or not, resistors do catch fire. They don't only glow very bright, okay, and become extremely hot and produce tons of smoke. They actually they do catch fire, and I've had circuits which have caught fire in the past because some complete idiot had plugged the wrong bloody values in. But, yeah, this is why you set up your circuit. Okay, so what do you do first? Alright, well, switch off your output, okay, to make sure these terminals are off. The TOPS one, you can't do that. Some other power supplies you can't do that. When you actually press the power button, they actually start producing a voltage at the terminals. So that's why you never ever plug in any wires. Okay, this one's got a failsafe, but if someone had left it on, which they had done, okay, you burn out the circuit and you just switch it on if your cables were connected. So never have them connected. Disconnect your cables, switch it on. Switch off the ports, okay, your terminals if they are on, and then it gives you a display of how much current, okay, this unit could supply up to. And I say could, not it will, it could, because current is determined by your circuit. So first things first, we turn all our knobs down to 0. Okay, first thing, you set your current limit to, I don't know, to whichever current you need to operate your circuit at. Okay, if you know what the current is, how much current you're going to be drawing from the power supply, it's always a good value to set this, okay, very close to it, okay, not below it, just slightly above it, above what you need, okay, that's always a good thing to do, because if you do get a short circuit, you're not going to draw any more current than what you've told it to supply you with. So if you do get a short circuit, or you do plug in the wrong component value, draw excessive current, you're not going to damage your circuit. So it's a good fail safe. Okay, so set your current. So let's say I want 200 milliamps. Is the maximum for my circuit. So let's turn it up to, say, 210. Okay, 0.21 amps, 210 milliamps. And I want a voltage of, let's say, 5 volts. So you turn the knob and you get roughly 5 volts. And as I said, you've got coarse, which you steps it up in large increments, and you've got a fine control as well. So if you find that you can't get it to a whole number or a particular value that you want, use both. Set the coarse a little bit low, turn your fine up. Okay, or you can set the coarse a little bit higher and turn your fine lower. Okay, it gives you that extra little bit of control. And here we have it. We've got our 5 volts at 201 milliamps current drip, and you can then plug in your cables and press the on button, and there we have it. Our current goes to 0 because nothing's connected. We're drawing 0 current. If we did have these connected, you would see this start drawing a current. Okay, just bear in mind this is hundreds or tens of milliamps, it's not milliamps, so you may not actually see this displaying anything. It's particularly low current, your circuit uses low current, but it's always good. It's a good idea of whether your circuit's drawing a current and how close you're getting to that current. Right then, new day, let's finish this guide. And then I told you all about how to use these power supplies that are on my desk. Gave you the basic run through, some of the do's, some of the don'ts, and now I'm going to show you some other common uses. Okay. Now then, we covered just using basically one socket on the power supply, one set of sockets, positive and negative, but in a lot of engineering, okay, we use what we call split supplies. Okay, and that could be that's when we use multiple power supplies. Okay, and we might be using positives and negatives, and other positives and other negatives. Okay, multiple supplies. Example of that would be take the switch mode power supply of your computer. Okay, maybe not if you use a laptop. Okay, but it does all the voltages internally to the laptop. But on a standard desktop machine, on an Apple desktop or a PC, Linux box, whatever you want, it's got a switch mode power supply in it, and it does multiple voltages, positives, negatives, 3.3 volts, 5 volts, 12 volts, minus whatever volts, okay, and so on. And what I'll show you now is how you actually get a multiple outputs off a DC power supply. So we'll do it on the whiteboard. Okay, don't need to show you that now because you know what it looks like already, and we've already played with it. So on our TTI, on our TOPS box, okay, we've got essentially we've got 6 terminals. Okay, we've got ground, we've got a 5 volts, and we've got plus and minus, 0 and plus. Okay, and if you want to use multiple supplies, then you connect the zeros together to earth, and you've got your 5 volts, your minus whatever, and your plus whatever. Okay, simple. You've got your plus and minus and 0. On the TTI one, okay, they're all potential voltages. A little bit different because we've got 1, 2, 5, 7 sockets. Okay, this one is earth socket. We've got negative, positive, negative, positive, negative, positive. Okay, no zeros. Okay, and no negatives and no positives. Remember that these are potentials. Okay, potential between the two. Voltage potential, neither negative or positive. It's somewhere. It's a potential, and it's up to you to tell it whether it's negative or positive. So, if we want again 5 volt supply, use the centre one because we can turn it to 5 volts. Okay, it goes from 1.5 to 5 volts. We can use that as our 5 volts. We want this to be plus 5 volts. So we connect our negative to earth. Okay, we've got plus 5 volts. Okay, we want a plus 12 volts. We set one of our 0 to 30s to 12 volts. That's 12 volts positive or negative, potential of 12. Okay, we want plus 12. We connect the negative again to earth. Now then, we want minus 12. We set this voltage to 12 volts. Okay, remember it's not positive or negative yet. If we want minus voltage, we connect the positive to earth. So we've now got a positive 12, a positive 5, and a negative 12. Okay. So we're forcing this positive to 0, so it means 5 volts below 0 minus 12 volts, not 5 volts. So we've got 12 volts below 0, because this is connected to essentially earth, 0. Okay, 5 volts above 0 and 12 volts above 0, because these are all connected to 0. Simple, that's how you get a split supply. And that's how you reference all of your zeros so that everything has the same potential. Okay? Because if this was, say, from 100 to 112, this one was, say, I don't know, 50 to 55, this one might be 0 to 12, okay? 0 and 12, the potentials, okay? The differences are all the right values, but the zeros are all over the place. So if you didn't have a common reference, okay, if you didn't zero them all, your power supplies will be all over the place, and your circuit will have different potentials all over it, and all sorts of weird things will happen with your circuit. It won't work in the slightest. Okay, and not only that, current flows from positive to negative, or negative to positive in the case of a negative voltage source. Okay, so you have to be careful that they all flow back to the same point. Not back to the individual suppliers, but back to the same point of reference. Okay, so current all goes and flows to the same point. And that's why. But when you come into practice and do this on your power supply, don't get into the habit of connecting every single cable you got to the socket. Otherwise, you've got your socket here. Okay, it looks something like that coming out of the machine, and you've got all your plugs. You've got one on here, you've got another one, all attached to it, and you end up with this huge stack of 4mm plugs hanging out the back of your equipment. Okay, what will eventually happen, because it's so long, okay, and they're not particularly that strong, what can happen is if you knock this, you can actually break the metal 4mm plug. So instead of connecting them all to the same point, what you can do, okay, you want them all to be at the same potential still, but what you can do is you can daisy chain them. Okay, so you just have 2 plugs in here, 2 plugs in here, 1 plug in this one, 1 plug in this one, and to take the 0 down to your circuit, you can have a wire coming from there. Yeah, so you've got 2 plugs, 2 plugs, 2 plugs, 1 plug. You're not overloading the sockets, you're not putting that weight on there, you're not got a million and one cables hanging off all of one socket. It makes it a lot neater and a lot easier to work with. So we've got minus 12, plus 5, plus 12, and 0 volts. And that's how you set up your power supply, and you can do this with more or less any power supply. You can only do this sort of arrangement with a floating supply, and you can tell it's a floating supply or potential because it's got positive and negative. If it's got 0 volts, okay, it means that this is actually 0. Okay, you can't force it to be negative. It is a positive voltage, so be careful. 0 stated, it is 0. It's not a negative. If it is a negative and a positive, then you can swap them. And that's your power supplies. See you next time on the next guide.